System of linear equations. Linear equation in one unknown. An equation that can be written in the form ax plus b equals 0 will be linear equation in one unknown. So here the unknown will be x, a and b can be any number. So for example, 2x plus 5 equals 0 is linear, but 2x squared plus 5 equals 0 is not because of the term x squared. So the x has to have only one as exponent, no other exponents. Linear equation in two unknowns, an equation that can be written in the form ax plus by equals 0, where x and y are some variables, a and b are constants, will be linear equation in two unknowns. For example, 2x plus 5y equals 0 is linear, but 2x plus 5xy equals 0 is not because of the term 5xy there. Here the 0 can be any constant, so instead of 0 let's make it c here. So even having 5 here or 3 here will be another example of linear equation in two unknowns. A solution to linear equation with two unknown will be any set of numbers, one for each variable that satisfy the equation. A solution of system of simultaneous linear equation in two unknowns is any pair of values x, y that satisfy both equations. In other words, graphically that solution will be the coordinates of the point of intersection of the two lines. So when we have two straight lines, we have three different scenarios. We might have those two lines intersecting at one point, and that point would be the solution. Another case possible is those two straight lines keep running parallel and they never intersect each other. And that will be the case where we have no solution for those two equations. And third case possible is those two straight lines can overlap each other, meaning that they are on top of each other. In that case, they intersect each other at many points, and those all points will be solutions of those systems. The first case I mentioned, where we have one single point as point of intersection, that system we call consistent and independent system, where we have one solution. When we have two lines which overlap, so the third case in my example previously, if two lines overlap each other, we call the system to be dependent system. And in that case, we have infinitely many solutions, and the system will be still consistent. In the third case, where two lines run parallel, two linear equations will never intersect each other, and those systems we call inconsistent system, and they are still independent system. And there will be no solutions to those systems.